Okay. Hi, Tech Rabbit here again. Thought we'd talk a little bit about controlling this laser diode module and how one can do it safely from an Arduino or any other digital logic source. So what I did is I set up a little experiment here. So what I've got here is a signal generator that just outputs some logic, 5-volt logic, and then I have my oscilloscope here that's measuring the output of the signal generator, and then the actual signal that goes to the voltage that goes to the laser diode. And here I have a simple relay module, and these one can get very cheap from the usual places. And the good thing about a module compared to just having a relay is that the module usually it contains a state diode in LED that indicates if it's on or off. And it also has the integrated, most of them have integrated overvoltage diode protection, so that the circuit controlling it doesn't get fried by the coil backlash that you would have if you just have a standalone, just the relay with the coil being excited. There you can get these relay module such, you can get them as like one relay, or with 4, or with 8, or I've 16. There's many different variants, but here I have the one that came with one of my kits, which is just a single relay module. And usually what you have to wire the relay up with is you have to give plus 5 volts ground, and then the actual logic signal that's going to go into this module. The problems one usually runs into is, like in this case, this specific module, there's no markings. It doesn't tell you that you need, you have 3 pins, so you can maybe guess that you need 3 wires, but it doesn't clearly indicate which is plus 5 and which is the ground and which is the signal pin. So I actually had to Google it. And this, when you buy these modules, you have to be very careful that if you look on online examples how to wire it, that you actually have, just check in the picture how the components are laid out. Usually if you have the same component layout as is on the circuit board you have for the module, then you can be pretty sure it is the module, even if it's called something else, because they can also call them different things, so you can't really search by type number. But anyway, this is good, because then the logic signal that's coming in here, it's not going to be feeding much current into this. This has its own control chip that will activate the relay itself, so then it's Arduino safe. This message is Arduino safe. So usually the issue becomes is that, like, okay, so how fast can you switch the laser diode using a relay? Because in this case, this is not a solid state relay, so it's not semiconductor logic. It's actual physical contacts that open and close. So you get a bit of a delay in the on-off function. And plus there is a limit to how fast you can activate and deactivate the laser diode. So the reason I set up this signal generator, and this is a very cheap signal generator, can recommend for hobbyist use. And this box is misleading. This actually doesn't contain anything. I don't know why they put it in such a big. It's very light. It's light as a feather. It's not more heavier than you would think a plastic box of this size to have. But I think it's base functionality. I mean, you can have various different types of waveforms and the usual offsets, you know, and frequency setting and amplitude. It hasn't got a very big amplitude in this specific signal generator. I mean, I'm mainly using it for 5-volt logic. But anyway, what we could do is to now I've got it wired up with the you know, the plus 5-volt feed from my power supply, and then the, as I said, the control logic, the control signal comes from the signal generator, so I can actually put it on. Oh, now I'm going to put the power supply on also. So here you hear it clicking away, and then you can see it in the oscilloscope also. Now, of course, when one's filming and then having a picture of the oscilloscope, there's going to be some kind of a frame delay. So, but I mean, this is okay. This is blinking once a second, and if one increases it, that's 10 times a second. Let's see if I can actually. Oh, just like a few more pulses than that. Oh, too much. There. So now one sees the pulses, and there really isn't much of a delay between the activation signal and the actual voltage that's applied to the laser diode. So if I just stop the run so we can have a look at it, maybe we zoom in a bit like that. So you see there's always a bit of a delay. Activation and then the relay activating, and then the signal coming off, and then the relay unactivating. So no one sees that there's a bit of a delay. But it's yeah. I think the time division is 10 milliseconds. So that's like maybe 5 millisecond delay in each part. But as I said, it's current safe, so you know, and you could probably operate it at something like 10 Hertz for in hobbyist use for quite a bit of time without actually having any problems. Then I'll free up the execution again, and then we put it up to 20 Hertz. And then you can see that the delay is pretty much staying the same. It's still in the range of 10 milliseconds. So if I stop it, then it's not really that much difference. And then what I was thinking of doing is that we don't go through many steps. Now we're going to go directly for 100 Hertz. And then you think that the waveform, you know, the actual activation and deactivation of the voltage to the laser diode it's getting malformed, so you don't, you know, it can't handle the signal to the relay, and the yeah, this is the control signal here, and then here's what's the relay is doing. So it's actually losing the battle to keep up. And I think when we go to 200 Hertz, it's just going to, yeah, then it stops working. You can't move fast enough. The mechanical delay gets too much, or something else in the electronics gives up. So I would say that so that we don't have to spend a lot of time on this, because it's probably not interesting to doing it online, is that I would say that around, I would say 50 Hertz. I would say, in all fairness, around 50 Hertz. You can then, except for the 5 millisecond delay in activation and deactivation, that you can, it's pretty stable. So here we say the waveform. So here we see the waveforms. That's pretty stable. And yeah, I think this is an acceptable solution if one doesn't want to use the laser diode signal for high-speed communication, or very accurately timed coordination between the electrical signal and the diode, then I think this, of course, this, as you heard, this makes noise, but of course it's amplified due to the platform I have it on, so it can actually be less noise if one isolates. And of course, there are many different types of relays, so this was just a random. I picked this randomly from the relay module kits that I have been, so I have several of these. I have module kits of like 8 relays and stuff, so they vary what relays you have. So since this is not for AC voltage, secondary AC voltage is not being switched, you could actually go for a very small mechanical relay, and that would be better, because the smaller the mechanics, the higher, theoretically speaking, the higher speed it could handle, so that you could actually, if you found a relay with much smaller electrical switching capabilities, then you would be able to possibly run it even faster. So that was my just a small update on controlling the laser diode with a simple relay. And in this case, of course, the input signal can come from the Arduino or from a switch, or so that's why I actually didn't involve an Arduino, because I thought I could just say that, I mean, this control wire could come from any device. And I wanted to concentrate on the switching, not the actual Arduino program. But I mean, you know, there are Blink programs and stuff for the Arduino, so it's not, that's not hard to find. So, let's see, was there anything else I was going to say? A relay module. Has to be a relay module, and then when you buy these modules, just try and double check that they actually have some electronics on the board that it's soldered on. There are some very cheap, they call them relay modules, but when you get them, then there's just the problem is that it's just the relay soldered onto a circuit board with no throwback protection diode, and no on-off indicating LED or anything like that. So those are bad. But it's in some markets they just want to fool people, because I mean, of course, it's still a relay module. I mean, you can use the name for it because it's still a module. I mean, it's a relay put on a circuit board, but there's no controlling assistive electronics. So okay, I think we wrap it up. That was a quick review. Can recommend the signal generator. A real cheap piece of equipment, and the box is completely fake. They could have delivered it with a box that's like a fifth of the size, and it would have still fit the stuff, because the power supply is also external. But it works. It works very well, and quite a nice user interface for doing things. Okay, see everybody later.